Hey guys, the very first conic section that we're going to kind of break apart and get some more information about are parabolas, right? And we've done parabolas, but we haven't necessarily done them to this level. We've looked at them more from what we did when we did quadratics, and we're going to use some of the same language, but we're going to take it a little bit deeper. So as we get into it, you're going to hear some kind of key words come out, and one of the first is the definition. So we're going to give parabolas a little bit of a different definition, but it's one that's going to have some words that will start to become more familiar as we do more and more with conics. So parabolas are the set of all points that are equidistant. Okay, so equidistant is an awesome word. And it just means that they're the same distance away, right? Equal meaning equal, distant talking about how far away. They're all the same distance away from something. And for parabolas, they're equidistant from a line. And that line gets a name that you saw maybe when you did some Desmos. The directrix in the given point. Which is the focus. Again, another word that we've seen before. So we are going to do kind of a dive into parabolas. So I'm going to draw a parabola, and this parabola opens up. It wouldn't have to, but I'm deciding that that's a good option. And let's start with some things we know for sure, and maybe we remember for sure. The very minimum or maximum of our parabola is the vertex. That should feel familiar. That's something that we used when we did quadratics. Another piece of information that we relied on was the fact that we could draw a line that would cut our parabola perfectly in half. And I'm going to take mine down a little further, make this more of an epic line. It's the axis of symmetry. And so the axis of symmetry, axis meaning line or dividing line or whatever, right? X-axis, Y-axis divides the top and the bottom of the graph, left, right, whatever. This divides our parabola in half. I'm going to be lazy and I'm just going to call it AS, but if you want to call it ASym or whatever works best for you. But those are some things that we remember. And so now I'm going to get into some things that are a little bit new and a little bit different and a little bit awesome. So the focus. There is a point inside our parabola called the focus. If you have ever, or if you have like satellite dish or like dish for your TV, you'll notice it's kind of shaped like a bowl, and then there's that little rod that sticks out of the middle. The reason is because as the rays come in to get you the TV, they all land on that rod, which is the focus. And that's super important for parabolas, and that's super important point for if you have a dish. And so if you want to get TV, all of the way the TV comes through has to land on that focus so that it can get pushed into your house. And that's why parabolas are so interesting, is because they are shaped in a way that that focus is a super important point. And that's another way to remember that the focus is inside the parabola. So that's part of our definition. The other part is something called the directrix. And that is a line perpendicular to our axis of symmetry on the outside of our parabola, okay? So we've got inside our parabola for our focus, we've got outside our parabola for our directrix. Those two are equidistant from the vertex, just like they're equidistant from any point on the line. But specifically from the vertex, this distance right here is P. Same thing down here, P. And that P is going to come in handy for us, and is going to show up in the equation. So we'll be looking to solve for P. So we're going to take a quick look at some information about parabolas. And so I'm going to give you two equations, and I'll explain the difference for them in a second. But let's get those written, then we're going to talk about a bunch of categories, or not categories, a bunch of characteristics for these parabolas. So here we go. The first is I'm going to look at x equals 4p. Tons and tons of letters today. I promise you'll be okay. And we'll make sure we give them all specific roles. So there's those two equations are the same. It's just a matter of is h attached directly to x or has it been moved to the other side? And we've kind of seen both. And so just being mindful of what really happens with that. The other version is instead of being x equals, we're going to do y equals. I'm running out of room over there. Okay, so those are going to be my equations. And again, you can't see them, so let's fix that. There we go. Again, they're very similar. It's just a matter of where is the other part of the vertex. So kind of underline them, and then we're going to take a deep dive into what they tell us about our graph or about our parabola. There are 7 characteristics that I'm going to kind of walk through with you. The first is which direction our parabola opens. We're going to talk about the vertex. We're going to talk about the focus. We're going to talk about the directrix, right? Those are those 2 key words. We're going to talk about the axis of symmetry. Again, I'm abbreviating, calling it AS, because sometimes I just gotta be lazy. And we're gonna talk about the focal length. And we're gonna talk about the focal width. And those last 2 are super interesting. I think they're super cool. We'll take a kind of a dive into what they tell us and whatnot. So I'm gonna start with this first equation. We're gonna walk through all of the details of that first, and then we'll kind of go from there. If y is being squared, that's not what we're used to, but if y is being squared, that means our parabola is opening to the left or to the right. And it all depends on that value of p. We open to the left when p is negative, and we open to the right when p is positive. In other words, what number is in front of our squared? Because that's going to tell us which way we want to go. The vertex is always at HK. If H is on X like it is in the bottom equation, we have to be a little bit mindful of making sure that we catch that X lies, and the same with Y lying inside the parentheses, and make sure we're being mindful of what our vertex actually would be. And that's something that hopefully that started to shine through in the Desmos a little bit. Now, we're going to talk about focus and directrix. The focus lives inside the parabola. So we're going to be moving with a parabola that's shaped kind of like this or like this. And so we're going to be moving our focus left or right further inside the parabola. So what we do is H, and then we're going to add P. And you're like, but Vista, what if we need to go to the left? Well, that means P is negative, and it'll totally take care of itself, I promise. The directrix goes outside the parabola, and that's where the minus P comes in to play. The axis of symmetry, it's just y equals k. The focal length is P. And then the focal width is the absolute value of 4p. Now, I need to backtrack a little bit because when I put the p information right in front of the squared, I screwed something up. So I want you to go back and I want you to turn this into a fraction. You know what? Let's really do this right. I made a mistake, okay? if I put it in front of the square, then I need to make it a little bit different. So I'm gonna fix both of these while I'm catching it because I don't want to give you bad notes and I want you to get this caught. So it doesn't change anything that we've written so far, except for the fact that part of it was wrong. So I'm gonna go back and every time I'm in front of a square, like we saw in our Desmos activity, we want it 1 over 4p. So we're actually gonna be thinking in terms of the reciprocal a little bit. Okay, so every single one of those says 1 over 4p. I know it's not ideal. Let me zoom quick. Whoops, wrong direction. Those all should say 1 over 4p. They're kind of a hot mess right now, but I'm hopeful that you guys can kind of see what you need to get yours fixed up. Okay, like I said, my bad. But I think that'll be a little bit more helpful and you'll start to see a pattern a little bit. As far as the other way, which is the y equals and x is being squared, these are the parabolas that we are used to. These are the parabolas that open up or down. Up, of course, means p is positive. Down means p is negative. The vertex is still at hk. Notice h always travels with x, k always travels with y. The focus, because our parabola is shaped up or down, the focus is going to be moving on the y coordinate, either into the parabola or moving further into the parabola. So instead of adding this p value to h like we did in the previous part, we add it to k. Now as we keep going, our directrix is going to be y equals k minus p. The axis of symmetry, focal length is still p, and the focal width is 4p. Focal width is just the width of the parabola at the focus. So if I come back up here and I said, how wide is my parabola at the focus? That would be our focal width. So when we're talking about that, if you see that come up, that's where that comes from. Kind of another neat detail we can talk about with parabolas, because there's lots going on with them, but it's all good stuff. So this one's a little long. Parabolas to me are the most complicated ones, so it's good to get out of the way. Please be in touch if you have any questions. I know you can do it.